Okay, here we have palmitic acid. This is a fatty acid. And then the question A, draw the molecular structure of a triglyceride containing only palmitic acid as its fatty acid. So the first thing is that we have to know what is the structure of the triglyceride. So it's basically an ester made of alcohol and carboxylic acid. And then we know that triglyceride means that it has like three arms, and then it contains the palmitic acid as it's only fatty acid. So in that case, triglyceride consists of glycerol, the reaction of glycerol, and three fatty acids. So in that case, basically we have C O, but then we have like 3C. This is the frame structure for the glycerol, but then we want to like making the ester. So in this case, this is the alcohol, but then it will connect to palmitic acid. So this would be like CO over here, and then we see this is from the structure. So we are going to have like CH3 from this one here, and then we have like CH2 for thin, and we have like COOH. Okay, but now the COOH is attached to the glycerol, making the ester group COO. So in that case, we are just going to write here CH2, which is for thin, and CH3. Now, because the palmitic acid is the only fatty acid, so the three here is basically the same. This would be the palmitic acid. Okay, so this is the structure of triglyceride, which is made of glycerol and palmitic acid. Now, writing the molecular formula for the palmitate triglyceride. Well, basically, we are counting the number of the carbon, and then the number of the hydrogen, and the number of the oxygen. So in this case, we have to write here. Now, the triglyceride are the basic ingredients for making soap, and then why the saponification reaction of palmitic triglyceride with potassium hydroxide. So basically, we have an ester, COO, which comes from the triglyceride, and then we want to react this with a base of OH minus. So in that case, we need to write the reaction. So the reactant is the triglycerides. I'm going to write here. This is from the glycerol, but then it forms ester with the palmitic acid. So in this case, we have this CH3, and this is also, we have ester with the palmitic acid, and then we also have here CH2, 14 CH3, and then we want to react this with potassium hydroxide. So here we have an ester over here. So this is the ester, COO. And then we know that the ester comes from alcohol and carboxylic acid. So basically we have like alcohol, that is glycerol. And then the other one is basically carboxylic acid. But then we know that if we have carboxylic acid in the basic condition, then we will have the carboxylate ion, the corresponding carboxylate ion. So we will have the product here. So the first one should be glycerol, sorry. So this one should be completed. So in this case, this one here, okay, this is glycerol. Okay, and then the other one is actually the palmitate ion. So what is palmitate ion? It is basically, we have like CO minus, right? And then the palmitate, the complete palmitate. But then we also know that it will have the ion pair with the potassium. So for example, we can write it down, potassium here, something like this, which means that the K plus and the palmitate ion form salt. So this is basically salt. And we have like 3 because it comes from 3 here. It comes from 1, 2, and 3. So we have 3. So this is the salt of palmitate. This is potassium salt of palmitate or potassium palmitate. I can also write that down. And then the next question, if the saponification reaction of 80.6 gram of palmitic triglyceride with that molar mass are used, determine the volume of 1 molar of potassium hydroxide solution required to saponify all the triglycerides. So basically, we want to calculate the mole of the palmitic triglyceride. So here, mole palmitic glyceride, which is basically 80.6 gram over 806 gram per mole. So we have like 0.1 mole. And then we know that from the reaction, it is basically 1-to-1 ratio. So the mole of potassium hydroxide is the same as the mole of the palmitic triglyceride. And then if you want to calculate the volume, that should be like mole divided by the molarity. So in this case, we have mole of potassium hydroxide, which is 0.1 mole here. And then the molarity of the potassium hydroxide, which is 1.0 molar. So in this case, we have 0.1 liter of potassium hydroxide needed to react with all the available 3 glyceride. Oh, wait a minute. Okay, so we have to add 3 over here. So this one has to be like twice. It's 0.3 mole. So here should be 0.3, and this one should be like 0.3 liter.